question number 11. You know that the area of the parallelogram is base into height. Okay, area of parallelogram is base into height. So using this and the figure, show that the area of trapezium is of the sum of the parallel sides into height. So we have to prove that is of into sum of the parallel sides into height. So this is what we have to prove it. So we know the formula area of trapezium is of a plus b into h or of h into a plus b. So we just learn the formula. So we have to prove it based on this diagram. Okay. So now here the main diagram. Okay, trapezium is divided into two figures. One is parallelogram and another one is triangle. We know that in a parallelogram opposite sides are equal. So here given this is a means, so this should be a. Opposite side should be equal. And total base is given as b. Then what about the base? Okay, base of the rectangle. So total is b. So this is a. This should be b minus a. So this part it will be b minus a. Then you can apply the formula. Okay, area of the total figure, that is area of the trapezium is equal to area of parallelogram plus area of triangle. That is the concept. So opposite sides are equal, and so balance will be getting b minus a. Okay, b minus a. If you want to find out area of the trapezium is equal to area of the parallelogram ABDE plus area of the triangle BCD. So the height for both the diagram, for both the shapes, height is same, h. Okay. Now, so area of trapezium is equal to area of parallelogram ABDE plus area of the triangle BCD. We are going to add both the areas, we'll be getting area of the trapezium. Okay, now come to the area of parallelogram. The formula is base into height. Okay, base into height. So base is a and height is h. Okay, base into height. Then area of triangle of base into height. Okay, of base is b minus a into height is height. Okay, next step, you just multiply 1 by 2 and h with inside. So I am just multiplying 1 by 2 and h. Okay, simultaneously. So 1 by 2 into b is 1 by 2b into h. Okay, 1 by 2 bh minus 1 by 2 into a. Okay, into h. So 1 by 2 into a into h. So next, rearrange. Now here I have a into h. Okay, ah term. Here also ah term. So I am just arranging together. So ah, that is 1 ah minus of ah. 1 minus of will be getting off. Okay, of ah plus of base into height. Okay, so balance this of base into height. So now we can just take, okay, for both height is common. Okay, height is common. I can just take height outside. So of into h into a plus b balance. Now this is the formula for area of trapezium. Okay, area of trapezium is equal to of h into a plus b. So we got the formula. The next one is question number 12. So by dividing a trapezium into two triangles, show that its area is of the sum of the parallel sides multiplied by the height. The same. Area of trapezium is of the sum of the parallel sides multiplied by the height. Okay. So now here the trapezium is dividing into two triangles. Okay, two triangles. Okay, so area of trapezium is equal to area of the triangle ABD plus area of the triangle ACB. If you are adding these two triangles area, we'll be getting area of the trapezium ABCD. So we know the formula for area of triangles, okay, of base into height. Okay, height is given as h. Okay, for both the triangles, so height is same, of base into height. So base is different, but the height is same. Okay, so you can write now. So area of trapezium is equal to area of the triangle ABD plus area of the triangle BCD. Use the formula of base into height. Of base into height. So for this triangle, okay, BCD triangle, so the base is A. Okay. So two triangles. One is of base into height. So another triangle, red color, okay, of base is A into height. Now for both height is common. Okay, for both h is common. Take outside. So balance b plus a. Balance b plus a. So therefore of h into a plus b. So area of trapezium is of the sum of the parallel sides into height. Question number 13 is, okay, show how can we use two identical copies of trapezium. Here we are going to use two exact trapezium to make a parallelogram. So how will you give as the formula for the area of trapezium? So from this also we are going to get the area of trapezium formula of h into a plus b. Okay, so I am going to choose two identical copies of trapezium. Okay, so I am just taken one is A, B, C, D, another one is M and O, P. So both are identical. So both are same, you can just say. So now while I'm joining these two trapezium, okay, so I'm just joining these two trapezium in this position, I'm getting so parallelogram shape. Okay, A, P, M, D. So this is the parallelogram. Yes, from this parallelogram, I have to get the formula for area of trapezium. Okay, so area of trapezium. So we know the formula for area of parallelogram is base into height. Okay, base into height. Right, so from this you have to get the formula for trapezium. Okay, so how will you get the formula for trapezium? Right, so here is the answer. So area of parallelogram is equal to 2 times area of trapezium. Okay, 2 times area of trapezium. Area of parallelogram is base into height. Okay, base into height into 2 times area of trapezium. So base of a parallelogram. Okay, base of the parallelogram is B plus A. So total is B plus A. This is B and A. So total it will be B plus A. So total will be having B plus A. So base and height is H is equal to 2 times area of trapezium. Now we just okay interchange. We have to find the formula for area of trapezium. So bring it to the side. So 2 times area of trapezium is equal to B plus A into H. Now you take this 2 to this side. So multiplication become division. Okay, of B plus A into H. Or we can write this is nothing but the formula. Area of trapezium is of, okay, of H into A plus B. So we got the formula of area of trapezium. So question number 14. Show that the area of the kite is of the product of its diagonal. So area of rhombus formula is of d1 into d2. Okay, the same formula only we are going to use it for area of kite. Okay, so let me show the diagram. So I'm just taking the kite A, B, C, D. Okay, A, B, C, D is a kite. So now the diagonal, I'm just taking one of the diagonal is D1. So another diagonal is D2. Okay, D1 and D2. Now the kite is dividing into two triangles. Okay, kite is dividing into two triangles. One is, okay, this is the triangle. ACD, one triangle. This is one triangle. So another one is ABC. Okay, this is one triangle. So area of the kite is equal to sum of two triangles. Okay, sum of two triangles will be getting the formula. Okay, so we know the formula for area of the triangle is of base into height. So of base of this triangle it will be D1. So height it will be OD. Now just consider this triangle ABC triangle. Of base it will be D1. And the height it will be OB. Height is OB. Now based on this OD plus OB. So we'll be getting so D2. So that is the diagonal 2. Okay, so let me explain. Right, so area of the kite ABCD is equal to area of the triangle ADC and area of the triangle ABC. Okay, now area of the triangle ADC. Okay, ADC, how we can write of base into height D1 into OD plus of, okay, this triangle. So area of the triangle ABC of base. Okay, base into D1. into height. Height is OB. Now for both D1 common. Okay, for both D1, so base is same. Okay, base is same. I'm just taking base outside. So OD plus OB. If I add OD plus OB, just add OD plus OB. So I'm getting as a D2. Okay, diagonal to D2. So therefore of D1 into D2. So area of the kite is of D1 into D2. So next question number 15. So three problems about fitting concurrent shapes together. Okay, so three conditions, three problems we have. This is first question. So rectangle ABCD has side AB and rectangle PQRS has a side 2A, 2P. Show that the PQRS has 4 times the area of the triangle area of ABCD. So does this mean that 4 copies of rectangle ABCD will fit into rectangle PQRS? So check and see. Okay, here the sides are doubled. Okay, the sides are doubled. Whether okay, this the area. Okay, area it will become 4 times. So ABCD they are asking. Okay, first area of the triangle ABCD. I have taken ABCD with the length is A and breadth is B. So side they have given two sides. One is A and B. Okay, next rectangle with the side. Okay, 2A. This is A means okay, this is A plus A, 2A. So B plus B, 2B. Now we have to check whether the area of PQRS. So 4 rectangle can be fit into the big rectangle. We have to check area of a rectangle ABCD. So for this one, length into breadth, A into B, A into B. So I'm just taking the whole area as A. Okay, whole area is A. Next, we come to this rectangle PQRS. Okay, so area is 2A into 2B. So 2A into 2B is 2 to the 4 AB. So instead of AB, I can write it as A. Okay, instead of AB, I can write it as A. So 4A. The answer is yes. 4 copies of ABCD will fit perfectly into PQRS. Okay, 4 copies. 1, 2, 3, 4. So exactly, it will be perfectly fit into the PQRS. Now the same as second one, if a triangle ABC has side ABC and triangle PQRS has a side 2A, 2B, 2C. Show that triangle PQR has 4 times the area of the triangle ABC. If the triangle area is double, so we have to prove the area is 4 times the area of the triangle ABC. So does this mean that 4 copies of triangle ABC will fit into triangle PQR? So check and see. So first I'm just taking the diagram ABC. Okay, ABC triangle. Okay, with the side ABC. Okay, with the side I can just take it. This is A. So B, C with the side ABC. So next, I'm just taking a triangle PQR. Okay, PQR. Now the side it will be 2A. So A plus A, 2A. Now this is B plus B, 2B. Now this is okay 2C. The sides are double. Okay, so we have to check. Okay, 4 times. 4 triangle can be fit inside the big triangle. Okay, according to the calculation. Right, area of the triangle formula. Okay, using the Heron's formula, A is equal to square root of S into S minus A, S minus B, S minus C. Now, if the area with the sides 2A, 2B, 2C, if the sides are increased, you'll be having, so S value. Okay, how will you find out S value? If the sides are increased, semi-perimeter. The semi-perimeter means you have to add all the sides and divide by 2. Okay, so you'll be having, so 2A plus 2B plus 2C. So divided by 2, right? So if you are dividing by 2, we are getting as 2 is common outside. So A plus B plus C. So divide by 2. Okay, 2 get cancelled. So you're just getting only semi-perimeter. S is we are getting as A plus B plus C. So for this semi-perimeter, it will be A plus B plus C by 2. Okay, here we'll be having, if you are adding semi-perimeter for this, you'll be getting semi-perimeter, it will be A plus B plus C by 2 will getting. Okay, here it will be A plus B plus C we are getting it. So that is 2 times. The semi-perimeter is double. Okay, semi-perimeter is double. So that's why we are just taking as, okay, 2s. In the place of semi-perimeter is 2s. And 2s minus area is, okay, side is 2a, 2b, 2c. Okay, just apply it. Now here everywhere, here 2, what is that? So from here, okay, in this 2 is common, I am just taking outside. 2 is outside, 2 is outside, 2 is outside. Okay, 2 into 2 into 2 into 2s. Okay, s minus a, s minus b, s minus c. Now just multiply it. Okay, 2 2s are 4. And okay, this also 2 2s are 4. Okay, this from this I can take 1. Okay, one more step we will write. From this 2 I can just take 1 2 outside into, from this pair I can just take 1 2 outside. Okay, so balance we are getting as the formula s into s minus a, s minus b, s minus c. Now this is the formula for area of this triangle. Okay, that's why it is taking as capital A, area. Okay, now this is only one time area, so this is 4 times area, 4 times. So the answer, therefore the answer is yes, you can fit 4 copies of triangle ABC into PQR. We can just take this triangle and you can just fit exactly 4 times is coming. Now this is 1, 2, 3, 4 times triangle. We can just fit into PQR triangle. Now the third one, okay. Here a triangle ABC has sides ABC and triangle PQR has the side 3A, 3B, 3C. Okay. Show that the triangle PQR has 9 times the area of the triangle ABC. So does this mean that 9 copies of triangle ABC will fit into PQR? So check and see. Okay. First, there is 2 times, the sides are increased 2 times. So here increased 3 times. So area of the triangle ABC with the side ABC is, okay, we are just taking. Now first we'll go with the diagram. Okay. So ABC triangle with the side A, so B and C. Now if the sides are increased to 3A, okay, now the side is 3A, so 3B and 3C. Okay. So apply the formula. Area of the triangle is the square root of S into S minus A, S minus B, S minus C. Now area of the triangle with the side 3A, 3BC. Right, so semi-perimeter, that is 3S into 3S minus A, 3S minus B, 3S minus 3C. For everything, from this you just take 3 outside, 3 outside, 3 outside. So 3 into 3 into 3, 3S. S minus A, S minus B, S minus C. From this, I can just take 1, 3 outside. And from this, 1, 3 outside. So 3 3s are 9. Okay, 9 into A. 9 into A. So the answer is yes. So 9 copies of triangle ABC can be fit into triangle PQR. So 9 copies. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 triangles are fitting inside the triangle PQR. So question number 16, they have given the figure like this. They are asking what fraction of the triangle is shaded. What fraction of the triangle is shaded? So they have given the triangle. So what portions are shaded? We have to check. Okay, for finding this, right, I'm just, okay, joining this, okay, from this to this. Okay, if I join, I'm just getting, so I'm just naming this area as A, this area, this triangle area is A, this triangle is B, this triangle is C, and this triangle area is D. I'm just making as A, B, C, D. Okay. So we know that, right? Here, this side of the triangle. Okay. Here, the triangle side is dividing into two parts. This is two parts. In this side is dividing into three equal parts. Here, two equal parts. Here, three equal parts. Two equal parts means we can say this is the midpoint. Okay, this is the midpoint. If I join, okay, if a line joining from vertex to the midpoint, I can say this is the median. This line is the median. So we know that median divides the triangle into two equal half. Two equal half. That means I can say area of A is equal to area of B. These two are equal. Okay. Next. So now this, if you are taking this triangle, this is the median. Okay. These two length are equal. This is the median. If I join these two line, now this is the median we can say. Okay. This is the median. Divides into two equal triangle. So area of area of C is equal to area of D. Okay. Area of A is equal to area of B. Area of C is equal to area of D. Okay. So in overall, just go with overall triangle. In a whole triangle, okay, the triangle is dividing into three equal parts. Overall triangle is dividing into three equal parts. Which triangle? This is one triangle. Okay, actually this is one triangle. Which one? So this portion. Okay. So this is one triangle. Next, this is another triangle. Okay. So this is another triangle, equal area. Okay, this is another triangle. So three triangles overall. Okay, the whole triangle is dividing into three triangles. So I'm just going the solution. You can just see here, right? So this is the figure. Okay, let area of the whole triangle is A. Okay, area of the whole triangle I'm just taking as A. Okay, A, B, C, D. This is D. So area of the whole triangle is A. So draw a line, split the shaded portion into two parts. So B and C, I'm just dividing it. Now we know that median of the triangle divides the parts into two equal area. Now here this is one median dividing into two parts. Area of A is equal to area of B. That's why you have written. Area of A and B are equal. The same as now this also is a median. So area of C and D are equal. Area of C and D are equal. Okay, as is the median. Now, so if you are adding B plus C, okay, this one is a shaded portion. If you are adding B plus C, so instead of B, what can I write? Instead of B, I can write it as A. Both are equal. Instead of C, I can write, okay, area of D. C and D are equal. Hope you can understand. Okay. Now, if you are adding, okay, adding A plus B, okay, if you are adding A plus B, okay, so A plus B in the whole triangle, A plus B is equal to, if you're adding these two, it will become a single triangle. Okay, if you're adding this, I'll be getting a single triangle like this. Okay, this single triangle, I'm just adding A plus B. Okay, if I add A plus B, it's equal to area of the triangle C. The same as area of the triangle D. Now we compare. So total we have three triangles. Okay, total area is A we have taken. So now A by 3. Okay, total area of the triangle is A. We are just dividing by 3. 3 equal parts. Okay, area of this A plus B is 1/3 of area of the triangle, whole triangle. Now just come to area of the triangle A alone. Okay, A alone. Okay, A is equal to B. How will you find out the area of triangle A alone? Okay, for that, right, so area of the triangle A alone, how to find out? Right, so for that, I'm just taking one more, the same triangle, right, for finding A alone. Okay, I'm just doing the construction here. Already we have joined this. This is we already joined, right? Now, So actually for finding this A part alone, okay, this alone A, right? Now this is just take, if I draw the line from here to here, this is one point. Okay, how in this triangle we have taken this as center and we have drawn the line. So we just divide it into two parts. The same way, so I'm just considering this the midpoint. I'm just drawing. Now if I take this is the midpoint, okay, I'm just joining this. Okay. Now if you are taking this alone is A, this is alone A. Okay. Now we want to find out. So total how many parts? So now actually this is 1, 2, 3, 4, okay, 5, 6. Okay, 6 parts. So if you want to find out area of A is equal to area of B. Okay, why? Because these two are both are equal in the beginning itself. So now area of A, how will you write? So total triangle is A. A is dividing into 6 parts. So A by 6. A by 6. We are getting this. Now you come to this, right? Area of B plus C. So we have to add these two. These two area only we have to find out. So B plus C you add. Okay. Area B we have get it as A by 6 plus area of C we got it A by 3. Now just add these two. Okay. We can take the LCM as 6 for making the denominator same. So here I should multiply with 2. Okay. 2. 3 2s are 6. So multiply with 2. So it will become 2A. Now both are having the same denominator. Keep the same denominator. Add the numerator. A plus 2A is 3A. Now we can cancel 1 3s are 3, 2 3s are 6. So A by 2. Now, right, B plus C, we got it as A by 2. Now we have to find the shaded region. So whole triangle is A. Okay, out of A, how much portion is shaded? A by 2 portion is shaded. Okay, so if you are just simplifying it, right? So A we can get cancelled or take the reciprocal and then multiply. So final answer will be getting us 1 by 2. That means area of the shaded portion is half of the whole triangle. Okay, now, okay, this one is easy. Okay, so now second part. So what fraction of the square is shaded? Okay, what fraction of the square is shaded? Okay, so square is shaded means, right. So in this case, taking the same figure, right? I'm just going to mark. Okay, so draw the line. I'm going to draw the parallel line. Okay, I'm draw a lines parallel to the side of the square and passing through each vertex of the shaded region. Okay, shaded region. Okay, this 1, 2, 3, 4. Okay, this is our shaded region. So I'm going to draw the parallel line to the shaded region. Okay, so we'll draw the parallel line. If we draw, okay, so this line parallel is parallel. Next, okay, so I'm just drawing a parallel line to the given vertex. Okay, parallel is the same as for, okay, horizontally. Okay, horizontal line. It is coming like this. Okay, next, next, and next. So now this is looking at graph. Okay, from this graph, okay, I can just easily find out how much portions are shaded. Okay, now the big square. Okay, square is dividing into, okay, 1 2 3 4 5. Okay, 5 rows. So 5 rows, 5 columns. So 5 5s are 25 small squares we have. Okay, 25 small squares we have. In this small 25 squares, so how much portions are shaded? We can just, okay, so find out. Okay, it's not exactly, okay, how much portions are shaded? We can just take it as this is, okay, completed means you can just take it as this is one count, 1. This combinedly you can just take it as 1. Okay, next, this combined you can take it as 1 now. Okay, then these two combine. Okay, these two combine, correct? 1 2 3 4 5. Okay, 5 parts. So out of 25, 5 parts are shaded. So 5 by 25. So the answer is 1 by 5. Okay, 1 by 5. Okay, this is easy to understand, right? Now, so question number 17. Okay, question number 17, they have given, okay, a rectangle. So inside the rectangle, we have 1, 2, 3 circles. So what fraction of the rectangle is covered by the circle? Okay, what fraction of rectangle is covered by the circle? So how will you find out area of 3 circle divided by area of the rectangle. So we have to find out area of the rectangle and area of 3 circles. So let the radius of each circle be r. Okay, radius I'm just taking as r. I take this as radius from here to here. This is radius. Okay, this also it will be radius, and this is also radius. This is also radius. Okay, let r be the radius of each circle. Then the rectangle has length of 6r. Okay, now length of the rectangle from here to length of the rectangle. So it will become, okay, actually this is radius means, so this is also radius. Correct? This is one radius. This is another radius. And this is another radius. Okay, so radius plus radius, radius plus radius, radius plus radius. So total we have 6 times radius. Okay, 6 times radius. And so now length it will be 6. Okay, so length it will be 6 times radius. And the breadth, okay, breadth. Actually, this is radius. This radius and this also radius. Okay, 2 times radius. We'll be writing as 2 times radius. Okay, now length of the rectangle is, if you are adding all the radius, 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 we are getting as 6 radius. And breadth is radius and radius, we are getting as 2 radius. Now next, area of this each circle. Area of each circle. Okay, area of each circle formula. Okay, pi r square. Area of circle is pi r square. So there are 3 circles. So the total area covered by the 3 circle is 3 pi r square. Okay, 3 pi r square. Now area of rectangle. Okay, rectangle is length into breadth. Okay, length is 6r into breadth is 2r. Okay, now 6 2s are 12 r square. 12 r square. Now the fraction of the rectangle covered by the circle. Rectangle covered by the circle is equal to area of the rectangle. Okay. So area of the rectangle, that is, so 12 r square, and area of 3 circles. So area of 3 circles is 3 pi r square. For finding the fraction of the rectangle cover means area of the circle, area of 3 circle divided by area of the rectangle. So you can just simplify it. So r square cancel. 1 3s are 3, 4 3s are 12. Now balance we are getting as pi by 4. Okay, pi by 4. Okay. So how much? Okay, what is the fraction of the rectangle cover the circle means pi by 4. Pi by 4. Now here 1, 2, 3, 4 circles. Okay, 4 circles. Okay, inside the rectangle. The same concept. Okay, what fraction of rectangle is covered by the circle? Okay, the same, we can just take radius r. Okay, and r. So radius r and radius r. So this side also will be having r. So it will become, so length of the rectangle it will become, so this also r. Okay, so r, and the breadth it will be, so this is radius and this is radius. So 2 r's. So we can just write now. Now this is radius. Okay, this is also radius. So how many times radius? 1, 2, 3, 4, 5, 6, 7, 8. So length of the rectangle is going to be 8r. Length of the rectangle is 8r. And breadth of the rectangle, so now this is radius and this is radius, so 2r. Okay, breadth it will be 2r. Okay, let me find out the same. For finding area of the fraction is shaded is, so let the radius of each circle is, I'm just taking as r. So length of the rectangle, okay, it will be 8r. So breadth it will be 2r. So area of each circle, the formula is pi r square. Okay, so area of each circle is pi r square. So there are 4 circles. So the answer it will be 4 pi r square. Area of 4 circle is pi r square. Area of rectangle, length into breadth. Okay, so 8r into 2 R. 8R into 2R. Multiply it. So 8 2s are 16 R square. 16 R square. Now the fraction of the rectangle covered by the circles is equal to area of 4 circle divided by a rectangle. Area of rectangle. That is 4 pi R square. So divided by 16 R square. So R square get cancelled. 1 4s are 4, 4 4s are 16. So the balance is pi by 4. Okay, pi by 4. This answer also pi by 4. So question number 18, use the above to make a conjecture. Conjecture means a statement. Okay, conjecture about the area occupied by the circle fitted into rectangle in the manner shown. Okay, test your conjecture for the particular case, 10 circle, 20 circle, 50 circle. Then prove your conjecture. Okay, so in the previously, if it's a 3 circle, 3 circles inside the rectangle, answer is pi by 4. If it's 4 circle also, answer is pi by 4. If it's 10 circle also, its answer is going to be pi by 4. 20 circle, pi by 4. 50 circle also, pi by 4. Okay, how we are going to, okay, prove. Okay, prove your statement. For proving this, right? So I'm just taking, now I can just see, okay, I have taken the previous diagram. If it's 4 circle inside the rectangle, right? So in general, okay, in general, how will you write? So if it's n circle formula is n into pi r square. If it's 4 circle means 4 into pi r square. 5 circle means 5 into pi r square. N circle means n into pi r square. Area of each circle is pi r square. Next, how to find out the area of the rectangle? So area of the rectangle is length into breadth. Okay, so length of, for example, this rectangle, length of this rectangle, how we can write? Okay, so 2 into 8R we have taken, this can be written as, so 2 into n is nothing but number of circle. Number of circle. How many circles we have? 4 into R. So 4 2s are 8 R. So we'll be getting as 8 R. So 2 n R. This is the length. So breadth is 2 R. So 2nr into 2r. We will be getting 4nr. That is nothing but, right? So we will be getting area of the rectangle. Okay, so now we have to find out the shaded region. Shaded region means area of the circle divided by area of the rectangle. Area of the circle is n pi r square divided by area of the rectangle is 4n r square. If you are just simplifying it, right? So n get cancelled, r square get cancelled, pi by 4. We are getting as pi by 4. So now this is a simple concept. We based on this we can go for 10 circles. So if you have 10 circle now, so 10 circle means just write. So in the place of n we have to take it as 10. Okay, 10 pi r square divided by 4 into n is 10 r square. N is nothing but number of circles. Okay, 10 get cancelled. 5 no. So r square get cancelled, pi by 4. If it's 20 circle means 20 pi r square divided by 4 into n, that is 20 r square. 20 get cancelled, r square get cancelled, pi by 4. If it's 50 circle, so 50 pi r square, so divided by 4 into 50 r square. 50 get cancelled, r square get cancelled, pi by 4. Okay. So this is a general case. General case. Question number 19. So you can just see the diagram here. Okay, 9 identical rectangles stacked together. 9 identical rectangles stacked together. So the figure shown 9 identical rectangles fitted together to make a large rectangle. The large rectangle area is 72 centimeters square. So area of this large rectangle is 72 centimeters square. Find the perimeter of each small rectangle. Okay, so we have to find the perimeter of each small rectangle. Here all the rectangles are in equal shape, but they have arranged in different order. Here they have arranged in length into breadth. In this, they have arranged is breadth into length. That is the thing. Okay, but everything is in the equal shape. Okay, in this piece, we can just consider this is A. Okay, and this is B. Okay, based on this, right, this is A and B, length into breadth. So area of the rectangle is length into breadth AB. They have given, right, so the total area, we have 9 rectangles. So 9 times AB is equal to 72 is given in the question. Whole area is 72. From this, if you are taking this 9 to this side, right, it will become a division. So 72 by 9 is 8. So AB is equal to 8. That means area of one rectangle is 8 centimeters square. Now we have to find the perimeter. For finding the perimeter from the figure, okay, from the figure, right, they have arranged the rectangle in different order. Okay, here they have arranged with length into breadth. Here, breadth into length. Okay, now just see here. If you are just taking this, so here how many times? Okay, length of this rectangular portion will become A plus A plus A plus C. So you're getting us 4A. Hmm? So now here the length of this rectangle, here B plus B plus B plus B plus B. So 5 times B we are having. But the both length are equal, right? So I'm just writing as 4A is equal to 5B. Correct? Actually here we are just taking as this is A and this is B. Okay. Different order they are arranging it. For this, we are getting as 4 times A, and here we are getting as 5 times B. So both are equal. Okay, this is two length are equal. So 4A is equal to 5B. Now take this 4 to this side. Okay, now they are taking 5 to this side. Okay, B they are finding. So 5 to this side. So it will become 4 by 5A. Now just take this B value and substitute in 1. Okay, in the place of B, you substitute as 4 by 5A. Now A into A is A square. Now take this 4 by 5 to this side. If I am taking 4 by 5 to this side, so it will become A square is equal to 8 is there, right? So this 4 by 5 it will become 5 by 4. Okay, 5 by 4. We can cancel 1 4s are 4, 2 4s are 8. So 2 5s are 10. So A square is equal to 10. So A is equal to square root of 10. Now B value, okay, B value is equal to 4 by 5 into A. Okay, 4 by 5 into A value root 10. Now this is our A value, this is B value. Now the perimeter of rectangle is 2 times L plus B or 2 times A plus B. So 2 times root 10 plus 4 by 5 root 10. Okay, next, how they have taken? Now we have to take, right, so common outside. Okay, common outside, what is common? Root 10 is common. For both, root 10 is common. I'm just taking root 10 outside. If I take root 10 outside, already 2 is outside. From these two, root 10 is outside, already 1, 2 is outside. I can just take it as 2 into root 10. If I take root 10 outside, here we have 1 plus 4 by 5. Okay, 1 plus 4 by 5. Now just simplify it. 2 into, okay, 2 into root 10. So take the LCM as 5. Cross multiply. Okay, 1 5 is 5 plus 4. Okay, now this is equal to 2 root 10 into 9 by 5. Okay, now just multiply it. Everything is multiplication. 2 9s are 18. So 18 by 5. Okay, root 10. So 18 by 5 root 10 centimeter. Now this is the perimeter. Okay, perimeter of one rectangle piece. Question number 20. Okay, show that the area of the shaded blue triangle and the shaded red triangles are equal. Okay, so blue area and red area, they are equal. We have to prove it. Okay, so actually this is the vertex and this we can just take it as Okay, by seeing this cell, we can just say, okay, 1, 2, 3. Okay, so they have divided into 3. Okay, 3 triangle with equal area. This area, and this area. We have to give the proof. Okay, we have to give the proof. Okay, how we can give the proof? They have given that lines from a vertex to the point of trisection of the opposite side. So trisection means dividing into 3 equal half. Okay, this portion is equal to this and is. So trisection means dividing into 3 equal half. That is given in the question. So as they given in the figure, they are dividing into 3 equal parts. That's trisection. We can say that. Okay, I'm just taking the triangle and just naming as this is A. So B, okay, C. Okay, A, B, C, and D, E. You can just come to this diagram. A, B, C, D, E. Is given that the vertex, the lines from the vertex to the point trisection. So dividing into 3 equal parts. Okay, now we can just find out area of the blue triangle. Area of the blue triangles, we know the formula for area of the triangle is of base into height. Okay, for all the triangles, the height will be the same. Okay, for all the triangle, if you are just drawing the height, so height of the triangle will be the same. Okay, right? If you just take the height, if you are drawing, so this will be the height actually. So this is the height. Okay, height of the triangle is going to be the same for all the triangles. Okay, for this triangle also this is the height, white also this is the height, and this also this is the height. So we already learned the height maybe lies outside of the triangle also. So 90 degree. Okay, where the perpendicular will form, that is the 90-degree line. Okay, now height of the triangle is going to be equal. Now just take it, area of the blue triangle is ABD of base BD into height H. Area of red triangle of base is EC into height. Okay, as they given this is trisector. Okay, trisection. So BD is equal to EC. Instead of BD and EC, both are equal. If these two are both are equal, then of BDH of BDH. So both it will be equal. As BD is equal to EC, so area of the triangle ABD is equal to area of the triangle AEC. So ABD is blue area, AEC is red area. So therefore, area of the blue triangle is equal to area of red triangle. Thank you for watching. Kindly like, subscribe and share. Thank you.